Hello class. So today we'll be starting with what we call integration. And integration, as maybe you might have already heard, is actually the opposite of differentiation. So integration is the opposite of differentiation. Now, in that case, let me give an example. So if we have that y is equal to 2x, and we're to differentiate y equal to 2x, it will be what? The y dx is equal to, remember, what will it be? Remember the power of x. The power of x here is what? Base power 1. And in differentiation, we know that you do what? You subtract that. It will be what? It will be 2x is power 1 minus 1, if you remember that. And then you also do what? You come down here and you also take that the initial value of your 1 and then you multiply it here, right? Then what do we have as the final value? We have this as the final value, which is what? 2, which is just 2, because x is power 1 minus 1 is going to give us x is power 0, and x power 0 is actually 1. So the value is what? 2 when you differentiate it. Now in integration will take back this differentiated value back to the integrated value. Back to the original value. Let me know it's been integrated. So in integration, we'll have that the integral of x of 2 with respect to x, that's what we call integral of 2 with respect to x. That's how we say integral of 2 dx is actually equal to what? Now taking it back, let me just take it back straight away. I don't want to show any formula later. So taking it back, we just have it as what? 2x. But in integral, we always put a constant value. Now I'm going to come back to this to tell you why we put a constant value, but just assume that we put a constant value of k. Some use c, some use k, some you can use any other letter you want, but I know the one you see most times is actually c or k. Okay, now let's now go into the formula for integration, the basic formula for integration. Oh, I'm very sorry for that. Let's go into the basic formula for integration. The basic formula for integration is actually this: that whenever you have your integral of your x with respect to x, then it's going to be what? X raised to the power of, I didn't put this. Whenever you have your x raised to the power of n with respect to the x, then to be x raised to the power of your n, add a positive 1 over n plus 1, and then at the end you also do what? You put in your constants. Let's call our constant k. Now with all this being said, let's now look at this initial question we tried to solve again. So we did integral of 2 with respect to x. Then what did we get? We had that it will be what? 2 raised to the power, what's the power? What is the x value here? The x value is actually like saying x is power 0, right? Because if 2 is just standing alone, then the x value is x is power 0. So we do what? X power 0 plus 1 over x is power 0. Sorry, there won't be any x again. So plus what? So we have plus 0 plus 1, so it will be 0, and then we have plus 1. And what? Remember, you add your constant k. So what's the answer we get at the end? We have that equal to, this will be equal to what? X plus 0 plus 1 will give us x, so that will be 2 raised power x over what? 1 plus k, and that's equal to what? 2x. So you see that 2x plus k is what we've gotten. So this is how you differentiate. This is how you integrate. I've differentiated a lot. I'm now confusing differentiation for integration. Okay, so this is how you integrate. Integration, remember, does what? It is the opposite of what? Differentiation. So it returns back everything you've differentiated back to its original value. But remember, we have a constant. Now this constant, as I said I will get back to it. This constant actually happens when you're working with an indefinite integral. So in integration, we have two types of integration, two types of integrals actually. So we have two types of integrals and I will treat them separately. So we have two types of integrals. We have the indefinite integral or indefinite integration, indefinite integral, and then we have the definite integral. Okay, so for now, we'll be basing our definition, we'll be basing our topic on the indefinite integral, but we'll also, I think I will still branch on this definite integral while the topic proceed, while we'll keep on going as the class continues. We'll get into the definite integral. So let's take a question, let's take more questions to see how to solve it. So let's look at this. If we're given something of this nature, we're given a value dy dx is equal to 30x raised to the power of 2, sorry, 30x raised to the power of 2 raised to the power of 2 plus we have plus 3, and we're asked to do what? To find the integral, integrate this, or they might tell you what is the value of y. So it can come in different form. They can say integrate dy dx for this value, or they can say what's the value of y. When they say what's the value of y, it's like asking you, they say what's the value of y, it's like telling you please just integrate it first, because the only way to get the value of y, which is the original value, is to do what? To integrate your differentiated value. So solving this, we have that the integral then of 30x squared plus 3 dx is equal to, you differentiate. Now in integration, you can actually pick integral once there's a plus sign or a minus sign, then the integral can be separated for each value. So I can take it as integral of 30x squared dx plus 3, that integral of 3 dx. Okay, now when you're solving for a constant value, when you're trying to find the integral of a constant value, so just for example, now let me just come down here and just show this. If I'm trying to find the integral of a constant value, let's call the constant value n, and we have, let's say, nx dx, then I can take out my constant value outside of the integral, because integration doesn't really affect the constant value. So it will become something like this: n integral of what? X dx. What if it's just only n, like we have here, just only 3? Like we have, it will be what? The integral, if we have just integral of n dx, is like just saying n integral of what? Dx. Is that okay? Because this dx is having what? An invisible 1. So it's like saying 1 dx still, and then what is your integral of 1? Is still going to be, it will now give us what? X. So this will actually give us what? It will actually give us, sorry, to actually give us nx as your integral, then plus your constant. Okay. Here will give us, when you integrate your x only, you have what? N x squared over 2, right? And then we have your integral, your constant, sorry, k. So I just wanted to just bring this up before I begin to solve this question. So solving this particular question, we have 30x squared dx will be what? When we are integrating this, so I can bring out my 30, and then I put my integral of what? X squared with respect to x, plus I can bring out my 3, and I have my what? Integral of the x, and that is equal to, let me take this entire thing off. Okay, so here we equal to what? We have our 30 still outside, and then we have our integral of x squared dx will give us what? Remember, what's it going to be? You have it as x squared plus 1 over 2 plus 1 according to integration, plus what? Here will be 3 brackets what? The integral of this x here will be what? X. And then please have only one constant value. Now you know that we broke down this integration, and you might be leaning to have plus k here and then plus k in the other side. No, just put only one constant value. You can only have one constant value in every integration. You can't have more than one constant value. Is that okay? So solving this, we have that x squared plus 1 will give us x squared 3, that's s cubed. So we have 30x cubed over 3, because 2 plus 1 is 3, plus what? 3x plus k. And then 30 divided by 3 will give us what? I think that should be 10x cubed plus 3x plus k. And this is your value. So this is the value of your y actually. So this is let's take one more question, and then okay, let's take as many as we can while we still have the time. Okay, look at this other question here. We actually integrate 1 minus x over x squared. Okay, or let's just use that s cube. So let's say s cube. So let's integrate this with respect to x. Now integrating this, we have this again. Let's bring it out. 1 minus x over s cube. Now this is the fun part. Sorry, with respect to x, this is the fun part of integrating this part. How do we solve this particular question? You can solve this by breaking them down, and when you break them down, then it simplifies everything. So how do you break this down? Remember, this can be broken down into two separate values, which will become what? Which is going to give us 1 over x cube with respect to x minus integral of what? X over s cube with respect to what? Dx. Solving this one, we have that this also can be simplified or can be written in its initial form as what? X raised to the power of what? Minus 3. If you remember indices, that whenever you have 1 over anything, it is actually written as what? The raised to the power of the negative. So x to the power of minus 3, integral of this, the x, minus. For this part, we know that x can cancel out one of the x here, and we have here remaining what? X power 2. And then writing it here, if it's x power 2, then it's like saying 1 over x power 2. And if you're writing it in integral in its initial form, it becomes what? Integral of x raised power what? Minus 2 dx. Okay, now we can now proceed in solving this. This is now easier in solving. So in solving this particular question, what do? It becomes what? X raised to the power of minus 3 plus 1. Remember, we're now applying the formula, and there will be what? Minus 3 plus 1. Then we have this as minus. Here will become x raised to the power of minus 2 plus 1 over minus 2 plus 1. And then finally we put in our constant plus k. And this is equal to minus 3 plus 1 is minus 2. So we have x power minus 2 over minus 3 plus 1 is what? Minus 2 as well. Minus x power minus 2 plus 1 is minus 1. And here is minus 1 plus our constant value k. So solving this part, we have that the minus sign, remember, minus can never remain in the denominator, so it comes up to the numerator, and we have this as minus x squared, x raised power minus 2. So we have this as let's put it at just minus 1. Let's bring out this as minus 1 over 2, and then we have it as minus 1 over 2. Here is x raised power of minus 2 minus, so when this minus comes up, it changes its minus to become plus. So here's plus x raised power minus 1 plus k. And I can just round this off by opening this x, that's putting this back in its normal form, which is x power minus 2, taking it away from the initial form, and it becomes what? Minus 1 over 2. And let me spread this, x raised power 2 plus, here becomes also what? 1 over x, and then plus k, and we are done. We can say this is the value of our x, this value of our y when we integrate this value. And let me take the last question, and after that we'll go into another video where we'll talk about maybe bringing in trigonometry, bringing in exponentials and logarithms to solve it. So okay, let's take our last question. What if we're asked to differentiate this question? Let's say we're asked to differentiate, it integrates. We say it integrates. Let me write that better. Integrates x squared plus 3x plus 2 over x plus 1, all with respect to x. That's dx. Okay, so let's see how to work on this. Now, to solve this particular question, it looks daunting at first, but the best thing to first is what? Simplify. Now, the trick about integration is not, don't go head on immediately. Start by solving it normally, like how you would have worked with it on normally, on a normal base, before you begin to apply the integration. Integration should be the last thing you do when you have a complex question. You first of all start breaking it down, break it down, break it down, break it down, break it down until you feel like, okay, I've broken it down as best as I could. Then you integrate. Okay, so solving this question, as I told you, I'm going to forget about the integration aspect and start working on this. So the first thing I do when I'm working on a question like this, I first start by simplifying it. And in simplifying this, I can see that I can factorize this quadratic expression. Now, factorizing this quadratic expression, what do I get? Here becomes for x squared plus 3x plus 2. Remember, how do you factorize this? Let me just remind you again. You look for the value of AC. You can go back to my video on quadratic expression, so I will not talk a lot on this. Look for the value of AC. The value of AC is like saying 1 multiplying 2, which is going to give us 2, and then the value of B is what? 3. So we look for two values that when we multiply it we get 2, and when we add that same two values we get 3. And what are those two values? It's going to give us 2 and what? And 1. So therefore we take these two values and we substitute for the value of what? B, and that will become x squared plus 2x plus x plus 2. Remember, if you don't know how to do this, then please just go back to my video I did on factorization in quadratic expression. I did a whole, over how many videos on that? Okay, so in this part I can break this down again. I can do by grouping. So what do I do next? What is common? The highest common factor between these two is what? X. So you take them pair by pair. Here's x plus 2, and then here will be what's common between these two is just 1, because nothing is common, so 1 is always the one that is a factor of the both of them. So plus 1 bracket x plus 2, and then we have, remember we're still on integration, over x plus 1 dx, and then what do we have here? Integral of, we group them now. By grouping it we bring x plus 1, and then we have x plus 2 over x plus 1 dx. Now notice something here. This can cancel out this, and once this can cancel out, then it simplifies our working, and that means we are actually, in actual term, we're actually integrating only x plus 2, all with respect to dx. And so in integrating this, we know that the integral, we can break it down into separate ones, but I hope from next time I will no longer need to break it down. I'll just solve it straight away, because I want you to be able to follow me without needing to go through all the primary aspect of what we are doing. So this will then be equal to what? Integral of x dx will give us what? X squared over 2, plus integral of 2 dx will give us what? 2x, and then you bring in your what? Your constant value. And then this is the answer. So when we're solving questions like this, remember, starts by simplifying it. Start of all by simplifying it, and then when you're done simplifying it, then you apply your integration. I hope this was okay. You understood this. If there's any question, please drop it in the comments section, and I will see you in the next video, still on integration. Thank you.